In 1933, a crew of divers dropped 90 feet into the Pacific Ocean to build something that had never been attempted before: a bridge foundation in the open sea. Not in a river, not in a harbor. In the Pacific, where more than 2 million cubic feet of water raced through the strait every second. The tidal current hit 7.5 knots. Visibility was 0, and they had 20 minutes to work before the ocean took the site back. 3 times, the Pacific destroyed everything they built. 3 times, they started over. This is the story of the machines that built the Golden Gate Bridge. The Golden Gate Strait sits at the mouth of San Francisco Bay, where the Pacific Ocean funnels through a channel only 1.25 miles wide, but up to 335 feet deep. The currents here move roughly 3.5 times more water than the Mississippi River. The San Andreas Fault runs just 12 miles offshore. Fog rolls in without warning, sometimes reducing visibility to less than 100 feet in minutes. Winds gust to 45 miles per hour, and the water temperature hovers around 50 degrees year-round, cold enough to cause hypothermia within 30 minutes. Ships passing through the strait had been running aground for decades. The bottom was littered with wrecks. Every engineer who studied the site in the early 1900s came to the same conclusion: a bridge across the Golden Gate was impossible. But one engineer disagreed. Joseph Strauss, a 5 feet 3 inches bridge builder from Cincinnati, Ohio, had designed more than 400 movable bridges across America. Bascule bridges, drawbridges, the kind that open and close over rivers. He had never designed a suspension bridge in his life, and yet in 1921, Strauss proposed spanning the Golden Gate for $17 million. His original design was a clumsy hybrid, a cantilever with a small suspension segment bolted onto it. The press called it ugly. Engineers dismissed it. But Strauss would not stop. He spent the next decade fighting to make it real. The obstacles were not just engineering problems. Southern Pacific Railroad owned the Golden Gate Ferry Company, and the bridge would destroy their monopoly. They filed more than 2,300 lawsuits to block construction. The United States War Department feared a bombed bridge could seal the harbor. San Francisco voters responded with a mass boycott of ferry service, forcing Southern Pacific to drop its lawsuits in 1932. But financing remained impossible. On November 4, 1930, voters in 6 counties approved a $35 million bond measure by a margin of nearly 3-1. Citizens pledged their homes, their farms, and their businesses as collateral. This was the middle of the Great Depression. Wall Street refused to buy the bonds. Enter Amedeo Peter Giannini. He was born in 1870, the same year as Strauss. When he was 7 years old, his father was shot dead over a $1 debt. The murder shaped everything that followed. Giannini grew up and founded the Bank of Italy in a converted saloon in 1904. After the 1906 earthquake, he set up a desk on the San Francisco docks to issue credit based on a handshake, while every other bank stayed closed. He eventually built Bank of America into the largest bank in the nation. He also financed the California wine industry, Hollywood studios, and Walt Disney's Snow White. When Strauss came to him desperate for funding, Giannini's response was simple. He said, "We will take the bonds. We need the bridge." Bank of America purchased $6 million in bonds, breaking the logjam and making construction possible. Workers were hired through Iron Workers Union Local 377. With 25% national unemployment, the response was overwhelming. Out-of-town job seekers bought addresses and social security numbers from San Francisco residents to meet residency requirements. Former farmers, clerks, and taxi drivers claimed ironworking experience. One cable supervisor, Charles Kring, later recalled that there was always somebody waiting at the base of the tower for someone to fall off so they could get a job. Union wages ranged from $4 to $11 per day, roughly $90 to $240 in today's money. Excellent pay during the Depression. But the 30 to 40-minute climb to the worksite every morning was unpaid. The wind at the top of the towers cut through every layer of clothing a man could wear. Workers stuffed crumpled newspaper inside their jackets for insulation. Strauss knew he could not design a suspension bridge himself. His entire career had been built on bascule bridges, not suspension spans. The engineering was completely different. So he hired Charles Alton Ellis, a mathematician from Wesleyan University, who held degrees in math and Greek, but had no formal engineering degree. What Ellis lacked in credentials, he made up for in raw mathematical ability. He turned out to be brilliant. Working 12 to 14-hour days from March to June of 1930, Ellis computed every structural calculation for the all-suspension design by hand. He collaborated by telegram with Leon Moissauf, the world's leading authority on deflection theory, in New York. Ellis designed the elegant steel arch over Fort Point. He wrote specifications for all 10 construction contracts. He submitted 10 volumes of hand calculations. But in November of 1931, Strauss ordered Ellis to take a vacation. 3 days before Ellis was scheduled to return, he received a letter that said, "Do not come back." He was fired. The official reason was wasting money on telegrams. Unable to find other work during the Depression, Ellis continued working on the bridge calculations for free, 70 hours per week, submitting his 10 volumes to the project without payment. When the Golden Gate Bridge opened on May 27, 1937, Ellis was neither invited nor mentioned. Strauss removed every reference to Ellis from the official report. A plaque honoring Ellis was not installed on the bridge until 2012, 75 years after it opened. Construction officially began on January 5, 1933. Workers started by excavating 3.25 million cubic feet of earth for the massive anchorages, blasting bedrock with dynamite and removing debris with high-pressure water hoses exerting 500 pounds of hydraulic pressure. 6 pilot bombs containing 200 pounds of dynamite each blasted the foundation holes. Separate concrete batching plants were built on each shore specifically for the project. Wet concrete was delivered across the access roads in trucks, carrying approximately 5.2 cubic yards per load. For the anchorages, wet concrete was poured through long tubes called elephant trunks into 12-foot thick blocks laced with reinforcing steel. Pouring rates reached 120 cubic yards per hour, and once the work started, the pumping could not stop, or the materials would not set properly. In total, 389,000 cubic yards of concrete would be poured across the entire project. Each anchorage weighed 60,000 tons, but the real battle was the South Pier. Located 1,125 feet from the San Francisco shore in open water, this would be the first bridge foundation ever constructed in the open ocean. Pacific Bridge Company of Portland, Oregon, won the contract for $2,935,000. Their first task was building an 1,100-foot timber access trestle from Fort Point out to the pier site. If you have been following this channel, you know that the machines at Hoover Dam faced some of the most dangerous conditions in American construction history. But the Golden Gate gave Hoover Dam serious competition because the Pacific Ocean was about to destroy that trestle 3 times in 5 months. On August 14, 1933, the SS Sidney M. Hauptmann, a McCormick Steamship Line vessel bound for Portland, lost its way in thick fog and plowed directly into the nearly completed trestle. 400 feet of timber access road vanished in minutes. 1 month of work, gone. Crews rebuilt it. Then in October 1933, high seas destroyed 3 of the 5 completed fender sections, along with the trestle end, sweeping construction equipment into the sea. Crews rebuilt again. Then on December 13, 1933, A 2-day southwest gale wrecked 800 feet of the trestle, leaving only 300 feet nearest the shore intact. Total delay from all 3 disasters was approximately 5 months. If you are enjoying this deep dive into Depression-era construction history, take a second to like and subscribe, because the trestle disasters were just the beginning of what the Pacific had in store for these crews. The trestle was finally repaired by March 8, 1934, and the real underwater work began. In the 1930s, divers wore hard-hat diving suits with surface-supplied air. Portable air tanks had not been invented yet. A diver's life depended entirely on continuous pumping of air through a long hose to the surface. The gate's vicious tidal currents allowed only 4 20-minute dive windows per day, when the tides changed and the currents briefly slackened. Some accounts describe the total usable working time as just 1 hour and 15 minutes across an entire day. Chief diver Chris Hansen and diver Bob Patching worked in near-zero visibility, feeling their way through murky water while tides bashed rocks and dragged debris through the darkness. Patching later recalled that at 50 feet, the atmospheric pressure doubled. It was strong enough to pin a man against a wall so he could not move. Despite the danger, men flocked to the underwater work. In Depression-era America, any steady, well-paid job was a godsend. The divers guided 40-ton steel forms into position entirely by touch. They connected wire detonator leads to underwater bomb heads. They smoothed the seafloor with 500-pound hydraulic pressure hoses. When underwater blasts detonated, the force threw dozens of fish out of the water onto the south shore. A detail you will not find in most documentaries: the workers held a fish fry that night. The original plan called for a pneumatic caisson to be sunk inside the fender structure. But after repeated construction disasters, engineers made a critical decision in mid-construction. They converted the fender itself into a cofferdam. The workers called it the giant bathtub. The fender was an elliptical reinforced concrete structure measuring 300 feet along the channel axis by 155 feet across, roughly the size of a football field. Its walls tapered from approximately 40 feet thick at the deepest base to 10 feet at the waterline, rising 15 feet above the surface. The total weight approached 130,000 tons of concrete. On November 27, 1934, workers pumped out 9.41 million gallons of seawater from inside the fender. The pumps ran continuously for days. As the water level dropped, the pressure on the fender walls from the outside ocean increased enormously. Engineers watched for cracks. If the walls had failed, the Pacific would have flooded the enclosure in minutes, drowning anyone inside. But the walls held. When the water finally drained, fish flopped on the exposed serpentine bedrock. University of California, Berkeley. Geologist Andrew Lawson inspected the rock and declared that when struck with a hammer, it rang like steel. On December 3, 1934, Chief diver Chris Hansen descended an inspection well to 107 feet alongside Pier Superintendent Jack Graham and resident engineer Russell Cohn to inspect the completed bedrock foundation. They found it ground to a true plane within 1/32 of an inch. The South Pier was the most expensive and most dangerous single element of the entire project. And it was finished. With the South Pier completed to its final height of 44 feet above water by January 3, 1935, the tower work began. The North Tower, built on solid ground at the Marin shore, had been completed months earlier with relatively few problems. The South Tower was another matter entirely. McClintic-Marshall Corporation, a subsidiary of Bethlehem Steel, won the superstructure contract for $10,494,000. This was the same company that had fabricated steel for the Empire State Building just 4 years earlier. They erected the two main towers using creeper derricks mounted on traveler trusses that climbed the towers in stages, advancing upward as each new course of prefabricated steel cells was riveted into place. Each tower contained approximately 600,000 rivets and 22,200 tons of steel. The towers rose 746 feet above the water, making them the tallest bridge towers in the world at the time, taller than a 60-story building. Steel was fabricated at Bethlehem Steel Plants in Pottstown and Steelton, Pennsylvania, shipped by rail to Philadelphia, transferred to barges, sent through the Panama Canal to Alameda, California, and then lightered by barge to the bridge site. The non-stop armada of barges delivering sand, gravel, cement, and steel resembled a wartime supply operation. If you watched our documentary on the Empire State Building, you already know the four-man Rivet Gang. The same crews that built skyscrapers in Manhattan built the Golden Gate Towers. The heater operated a small portable forge to bring rivets to approximately 1,900 degrees Fahrenheit. He tossed the glowing rivet through the air to the catcher, who snagged it in a metal can, sometimes across distances of 70 feet. The riveter drove the rivet home with a pneumatic air hammer, while the bucker-up held a bar against the manufactured head. Workers inside the hollow tower cells described the sound as deafening. But in 1934, something went wrong inside those tower cells. The steel arrived from Bethlehem, coated in lead-based primer paint. When glowing rivets struck the primer, the paint released toxic fumes in the enclosed space. Within weeks, 60 men were hospitalized with lead poisoning. Workers lost hair and teeth. They could not breathe deeply. One worker, Whitey Penela, described the conditions as horrifying. Strauss responded immediately. He ordered Bethlehem Steel to change the paint formula and contacted the E.D. Bullard Company of San Francisco to develop protective equipment. Bullard, founded in 1898 to sell carbide lamps to gold miners, had invented the hard-boiled hat in 1919, made from steamed canvas, glue, a leather brim, and black paint, with the world's first internal suspension system inspired by the World War I doughboy helmet. For the Golden Gate Bridge, Bullard modified the hard hat for construction work and designed the company's first supplied air respirator. A hard hat fitted with a canvas hood, a glass viewing window, and compressed fresh air pumped in from the bridge structure. The Golden Gate Bridge became the first designated hard hat area in American history. Resident engineer Russell Cohn enforced immediate dismissal for anyone who refused to wear one. No exceptions. The Bullard Company remains family-owned today, 5 generations later, and still supplies hard hats to Golden Gate Bridge maintenance workers, their longest-standing customer. We cover stories like this every week on Construction Legends. If you want to keep discovering the machines and the people behind the biggest construction projects in history, like and subscribe, and let us keep going. By the summer of 1935, both towers stood completed and ready for the cables. John A. Roebling's Sons Company of Trenton, New Jersey, the same firm that built the Brooklyn Bridge cables in 1883, won the cable contract with a bid of $5,855,000, beating U.S. Steel. The Depression had forced Roebling to lay off half its workforce. The Golden Gate contract restored 2,000 jobs in New Jersey and 500 in California. If you watched our documentary on the machines that built the Panama Canal, you know that the name Roebling has been connected to some of the most ambitious construction projects in American history. But the cable work on the Golden Gate Bridge was unlike anything Roebling had ever attempted. Each of the 2 main cables would contain 27,572 individual galvanized steel wires, each roughly the width of a pencil, with a tensile strength of 235,000 pounds per square inch. 80,000 miles of wire, enough to circle the equator 3 times. Cable spinning began in October 1935, but before a single wire could be spun, workers had to string temporary catwalks between the towers. These narrow footbridges, barely wide enough for 2 men to pass, hung from cables strung across the strait and swayed in every gust of wind. Workers crossed them daily at heights of over 500 feet above the water, carrying tools, with nothing below them but fog and the Pacific. The catwalks became the spinning platforms from which crews would weave the bridge's lifeline. Roebling had been contracted to finish in 14 months. They introduced several innovations that shattered all previous records. Double spinning wheels carried 2 wire loops per trip instead of 1. A midspan transfer station meant carriages only traveled halfway across the bay, swapped wires with an opposing carriage, and returned, eliminating dead return time. 4 carriages operated simultaneously, 2 per cable, and eventually 6 wires spun at once, color-coded to prevent confusion. The result was staggering. Where the George Washington Bridge had achieved just 61 tons of wire per day per cable in 1931, the Golden Gate reached 271 tons per day per cable, a 4.4 times improvement. Each spinning wheel crossed the half span in just 6.5 minutes. Crews laid 1,000 miles of wire per 8-hour shift. On May 20th, 1936, the spinning wheel was decorated with flags as it pulled the last wire across the bridge. Roebling finished in 6 months and 9 days, 8 months ahead of schedule, 4 times faster than anyone had predicted. It remains one of the most impressive feats of industrial efficiency in American construction history. The company had been given 14 months and a penalty clause for every day over deadline. They finished so far ahead that the penalty was never even discussed. After spinning, hydraulic jacks applying 4,000 pounds per square inch through 12 hydraulic rams compressed the 27,572 wires into the finished cable diameter of 36 3/8 inches. The thickest bridge cable ever built, each cable weighed approximately 12,000 tons and stretched 7,650 feet in length. They rest in 150-ton cast steel saddles atop each tower. At the anchorages, each weighing 60,000 tons, the strands splay into 61 individual strand shoes connected to steel eye-bars embedded in the concrete mass. Each cable exerts 63 million pounds of pull on its anchorage. With deck construction beginning in mid-1936, Strauss introduced the most expensive safety innovation in construction history. A safety net manufactured by the J.L. Stewart Company cost $130,000. That is roughly $2.5 million in today's money, spent entirely on protecting workers. No construction project in America had ever invested anything close to that amount on safety. The net measured 3,000 feet long by 25 feet wide, made of half-inch manila rope woven into 6-inch squares. It extended 10 feet wider than the bridge on each side and 15 feet past each end, suspended roughly 15 feet below the deck. At the time, the accepted rule in major construction was 1 worker killed per $1 million spent. On a $35 million project, that meant 35 expected deaths. Strauss intended to beat those ODDS. The net was not his only innovation. Workers received glare-free aviator goggles against Pacific reflections, special hand and face creams against the constant wind, carefully formulated diets to fight dizziness at extreme heights, and even sauerkraut juice dispensed as a hangover cure. 19 men were saved by the net. They formed an informal club called the Halfway to Hell Club. The name came from ironworker slang. When a man fell to his death from a bridge, they said he had gone to hell. The men who fell and were caught said they had only fallen halfway to hell. The club was formalized in December 1936 at St. Luke's Hospital in San Francisco. The first man saved was carpenter George B. Murray, thrown off on October 17, 1936. when a steel conveyor car lost control in heavy wind. Another worker, Ulysses S. Brown, fell alongside Murray in the same incident. Both bounced in the net and climbed back up to work. The most famous member was Al Zampa, who fell on October 19, 1936, in thick fog, flipped backward 3 times during a 60-foot drop, but the net on the Marin end sagged too close to the ground, and he hit the rocks, fracturing 4 vertebrae. Zampa spent 12 weeks in a steel back brace, then walked across an unpainted girder to prove he had not lost his nerve. He lived to 95. California later named the new Carquinez Bridge the Alfred Zampa Memorial Bridge in his honor. Another member, Pete Patterson, the 11th to join the club, bounced several times on the cord and simply climbed back up to his work. A famous Associated Press photograph taken December 14, 1936, shows 6 members posing near the San Francisco side. Some workers became so confident in the net they had to be threatened with dismissal to stop them from deliberately diving into it for thrills. For 3 years and 8 months of construction, not a single worker died on the Golden Gate Bridge. That record ended on October 21, 1936, when Kermit Moore, age 23, was killed when a pin atop a traveling derrick broke, dropping a heavy girder that struck him. At 9:20 in the morning on February 17, 1937, a 5-ton traveling stripping platform broke loose near the North Tower. This scaffold on wheels was being used to remove wooden concrete forms from the bridge underside. One set of wheels escaped its support rail. The unbalanced weight released the other 2 sets. The hooks and bolts holding the scaffold were undersized. That critical detail makes this disaster even harder to accept. A state safety inspector had condemned the San Francisco side platform that same morning for the exact same defect. But the warning had not reached the North Tower crew. 13 men were on or near the platform. Tom Casey lunged and grabbed a bridge beam, dangling with his pipe still in his mouth. A painter named Albert Ted watched from nearby. He saw the timbers and scaffold fall, and one red-haired man swinging from a beam bracket, still with his pipe clenched between his teeth. Steelworker William Dowell lowered a rope. Casey got his leg in the loop and was hauled up. Then he took the pipe out of his mouth. 2 other men also grabbed solid structure and were pulled to safety, but the 5-ton scaffold crashed into the safety net below. The net had been designed for human bodies, not multi-ton equipment. It held for a moment. Then it tore. Witnesses described the sound as the crack of a machine gun. Others compared it to a picket fence splintering. A section 2,100 feet long peeled away. 12 men plunged approximately 220 feet into the frigid water, entangled with scaffold debris and the net itself. 2 men survived. Slim Lambert, a 26-year-old championship swimmer, former cowboy and lumberjack, making about $10 per day, was struck on the head by lumber during the fall. The only thing that went through his mind was survival. He knew that to have any chance, he had to hit the water feet first. His legs tangled in the sinking net. He was pulled so deep his ears bled. He fought free, surfaced, and was rescued by a crab fisherman whose boat happened to be nearby. Lambert broke his shoulder, ribs, neck vertebrae, and both ankles. He returned to work 1 month later, against his doctor's orders. Oscar Osberg, age 51, a carpenter, was also pulled alive from the water with a fractured hip, broken leg, and massive internal injuries. 10 men died. Most bodies were never recovered. They were believed entangled in the net and swept to sea by the tide. The 10 men who died were Oa Anderson, Chris Anderson, William Bass, Odesper, Fred Damatson, Terrence Hallinan, Eldridge Hillen, Charles Lindros, Jack Norman, and Lewis Russell. Their families received no compensation beyond standard workers' insurance. A replacement net was installed on March 3rd. Construction continued on schedule, The 10 men who died that morning represented nearly all of the project's fatalities. Of the 11 total deaths during construction, 10 came in a single incident, on a single morning, 70 days before the bridge was finished. One of the most recognizable features of the Golden Gate Bridge almost never happened. Steel arrived from Bethlehem coated in a burnt red-orange anti-corrosive primer. Irving Foster Morrow, the UC Berkeley-trained consulting architect who had designed the tower openings, the Art Deco street lamps, and the pedestrian railings, noticed the primer's striking appearance while commuting by ferry. He saw how it stood out against the fog, the green hills, and the blue water. Morrow championed the color over fierce opposition and wrote a 29-page report arguing that this tone was luminous, underwent atmospheric changes with great beauty, and was prominent without insistence. He called black a dead weight, incompatible with grace. The Navy had wanted the bridge painted in black and yellow stripes. The Army had wanted red and white candy cane stripes. Morrow won. The color, later called International Orange, became one of the most recognized colors in architecture. Before the South Anchorage concrete was poured, Strauss placed a brick from his alma mater's demolished McMicken Hall at the University of Cincinnati inside the forms. It remains embedded in the anchorage to this day. On April 19, 1937, the roadway was completed. Edwin Iron Horse Stanley, the man who had driven the very first rivet on the project years earlier, ceremonially drove the last gold rivet on April 27th. The gold rivet was purely symbolic. It was replaced with a steel rivet minutes later. On May 27th, Pedestrian Day, 200,000 people walked, ran, and even roller skated across the new bridge, paying 25 cents each. The next day, President Franklin Roosevelt pressed a telegraph key in the White House, and the Golden Gate Bridge officially opened to vehicle traffic. In the first hours, 1,800 cars crossed. By midnight, 32,300 vehicles and 19,350 pedestrians had paid tolls. The Golden Gate Bridge was completed ahead of schedule and $1.3 million under its $35 million budget. It was the longest suspension bridge in the world, a record it held for 27 years. The bonds were fully retired in 1971, paid entirely from toll revenue. $35 million in principal, plus $39 million in interest, all from drivers crossing the bridge. But the men who made it possible did not share in the celebration, not one of them. Charles Ellis, the man who actually designed the bridge, was never credited during his lifetime. He died on August 22, 1949, teaching structural engineering at Purdue University. Whether he ever saw the completed Golden Gate Bridge before his death is unknown. Joseph Strauss disappeared for more than 6 months during construction without explanation, divorced his longtime wife, married a young singer, and after the bridge opened, resigned from the district and moved to Arizona. He suffered a heart attack and died on May 16, 1938, just 11 days before the first anniversary of his bridge. He was 68, and Leon Moiseev, the Latvian-born theorist whose deflection calculations made the Golden Gate possible, pushed that same theory too far. 3 years after the Golden Gate opened, Moiseev designed the Tacoma Narrows Bridge in Washington state, replacing the specified 25-foot deep trusses with 8-foot plate girders to save money. The bridge was lighter and cheaper, but fatally flexible. It earned the nickname Galloping Gertie because the roadway undulated visibly in moderate wind. On November 7, 1940, just 4 months after opening, Galloping Gertie twisted apart in 42-mile-per-hour winds and collapsed into Puget Sound. The footage is still shown to every engineering student in the world. Moiseev's reputation was destroyed. He died 3 years later, a broken man. The collapse triggered an immediate panic about the Golden Gate. Russell Cohn inspected the bridge and confirmed similar wind-induced motion. In a 1951 windstorm with 69-mile-per-hour winds, the Golden Gate roadway rippled 6 feet, and the bridge was closed for the first time in its history. A lateral bracing retrofit from 1953 to 1954 added so much steel that it made the deck too heavy for the planned second deck that would have carried rail service to Marin County. Moisseff's theory shaped Bay Area transit for decades. If this documentary gave you a new perspective on one of the most famous bridges in the world, like and subscribe, so we can keep bringing you these stories that nobody else is telling. The Golden Gate Bridge was built with machines that had never been tested in open ocean. Its cables were spun by a company that beat its own deadline by 8 months. Its foundation was poured inside an improvised cofferdam that was never part of the original plan. Its safety net saved 19 lives and could not save 10 more. And the man who designed it all was erased from history for 50 years. Today, the bridge carries over 40 million vehicles per year. The Bullard Company still makes its hard hats. The Roebling cables still hold, though inspectors have found corrosion in the outer wires that requires constant monitoring. The original International orange paint is reapplied continuously by a crew of painters who never stop. By the time they finish one end of the bridge, the other end needs repainting, and every rivet driven by those 4-man gangs in 1935 and 1936, heated to 1,900 degrees, tossed through the air, and hammered home 746 feet above the Pacific, is still in place. 1.2 million of them. If you watched this far, do us a favor and check out our documentary on the machines that built the Empire State Building in 410 days. Same era, same rivet gangs, same Depression-era desperation. That video is on screen now.